Hello and welcome to this second lecture from ACADS on Python programming. Today we are going to discuss elements of Python. A Python program is a sequence of definitions and commands, or as they are also called statements. The commands manipulate objects in the Python. Every object in Python is associated with a type. What is a type? So a type is a set of values and a set of operations that are valid on these values. The Python program also consists of expressions, and these expressions consist of an operation. That means it's an operator and the corresponding operands on which the operator will apply. We have been using types since our early days. For example, in our school mathematics, we use natural numbers, where values are 1, 2, 3 and so on. And the operations that are allowed on natural numbers are typically plus, minus, multiplication, division, less than, greater than, and so on. Okay. In contrast, we also have types like complex numbers. In this case, values have these two components, the real part and the imaginary part. So numbers like 5 plus 3i, 7 plus 2i, and so on. And there's a different set of operations which apply to these complex numbers. For example, plus, minus, multiplication, division. But you do not have less than and greater than for complex numbers. And even the operations like plus, minus, multiplication, division have different meaning when you apply them onto the complex numbers, and they have different meaning when you apply to natural numbers versus real numbers and so on. Okay. So what are the types in Python? So Python gives us certain basic types. So the important types we will consider are integers. So it's called int in Python, and this represents bounded integers like the number 732 or minus 5. So these are signed integers, which means you can have positive as well as negative numbers. Then you have floating point numbers, for example 3.14 or 2.0. And we will notice that floating point numbers are not exact. There are certain approximation. Okay, we will see this very soon. Then there are long, which are integers with unlimited precision, which means you can represent any integer no matter how big it is. And once again, this is a slightly complicated thing because computer memory is finite. So there are ways of creating these integers using software libraries. Okay. And finally, one of the most important types in Python is a string. So for example, if you type hello inside single quotes or C inside single quotes, or even inside double quotes. So these strings are an essential part of Python. So any questions till now? So Sridhar, please go ahead. You have to unmute yourself first.
Hi, Amay.
Hi,
is there a differentiation between a string and a char in Python, like other languages?
No, so Python does not have a separate char type. So characters are also represented as strings having single character. So if you can see in our example, the second element, capital C within single quotes, is a string as well as a character in Python. So Python does not have a separate character data type. Does this answer your question?
Yes, thanks.
Okay. So the types themselves can be divided into two categories. One is the scalar type. So scalar types are like atoms or individual objects that do not have any internal structure. So the scalar types in Python are integers, floating points, booleans, and a special type called none type. Now none type is a special type which has a single value. So remember, a type is a value and certain operations. So none type has a single value and this value itself is called none, okay, without any quotes or without any string double quotes. Okay. In contrast, there are types like non-scalar types. An example is string. These objects have certain internal structure. So for example, within a string, you can think about having separate characters or slices or parts of strings. Okay. So with non-scalar type, we can do certain kind of operations. We will see details of these operations very soon. Python has an internal function called type, T-Y-P. One example is shown. So this is again a sample session with IPython shell. This type can be used to find out type of any given expression or constant in Python. So for example, if you type TYPE and within parentheses 500 and press an enter, it will give you the type as int. You can also ask for type of -200 or type of 3.1413, and you can see that type of 3.1413, a floating point number or float. The Boolean type has two distinct values. One is called true, other is called false. And note that true starts with a capital T. So type of true with capital T is bool. Similarly, if you have any string within single quotes, its type is str. Note that you can use type function to find out type of expressions as well. So for example, if I ask is 3 not equal to 2, the result will be false is true in this case, and true itself has type Boolean. So the type will be of the result of evaluating the expression. So the type associated with the result of evaluating the expression. Okay. So any question up to this point? Okay, so then we will move forward. So in real programming, there are times when you need one type of object to use in a context where some other type is needed. So we require conversion of values of one type to another. And the typical example is integer to floating point conversion in mathematics. So remember, integer 3 is treated as floating point 3.0 whenever a real number is expected. So if you are trying to compute sign of something, typically you want real number or similarly square root of some number. You are working with the floating point numbers, but even there you can pass integer 3. And similarly, sometimes you want the approximate integer representation of certain floating point numbers like 3.6, and you can use either 3, which is the truncation, or you can round off 3.6 as 4. So we have been using these operations in mathematics quite often. The programming languages also support type conversion. In Python, type name itself can be used as type converter function. We'll look at certain examples. So if I say int of 2.5 on Python shell or in my program, it will result in a value of 2. Similarly, int 2.3 is 2 and int of 3.9 is 3. So one thing to note is that floating point to int conversion using int function is truncation. It is not rounding off. So you have to be careful. If you want to round it off, there is a different function. Similarly, you can convert integers to floating point number. For example, float of 3 is 3.0. And you can also convert strings into integer or floating point number or some other data type that you want. So for example, int of string 73 within quotes is going to be 73. So as you can see, this is very obvious. However, if the string does not represent an obvious integer or the type that you want, then you might get an error. So if I want to convert string accads as an integer, I will get an error thrown back at me, and you can find out that the message it says is invalid literal for int with base 10. So it is trying to interpret the string accads as a base 10 number or the decimal number, but it cannot find a suitable value for it. So it gives us what is called an exception in Python that we will cover later. As of now, we can think of it as there is an error in this program and Python has given us the message. Okay. So any questions up to this point? All right. We have few more conversion. So floating point or integer objects can themselves be converted into strings. So string of floating point 3.14 will be a string which contains characters 3, then character dot, character 1 and character 4. And similarly, string of some number will be the corresponding string having characters as the digits of the number. So type conversion is useful when you are reading input. So remember in earlier class we used this program where we were asking for age of the person and then we were just printing in back. But suppose we want to do certain mathematical operation with the value of age, the integer value of age. So this is a sample program which asks for input the age of the person. Suppose person says 35. Now we want to tell the user what will be his or her age in next 5 years. If we directly do age plus 5, as you can expect, we are going to get an error. Because Python does not know how to add an integer object to a string object. And it does not do an implicit conversion. So it gives you an error that it cannot convert integer to string. What you have to do is force the conversion, and this is the correct program. In 5 years, your age will be integer value corresponding to the string age and add 5 to it. So now the program will give you correct output. In 5 years, your age will be 40. Okay. You can try other combination like doing 5 plus age or multiplying by some integer and so on. Okay. I think you have done some of these in your tutorial where you mixed integer and string types for different operations like addition and multiplication. So any questions? Right. So now we come to the operators. Python support many different type of operators. Okay, so Mohit has a question. I am unmuting Mohit. Yes, Mohit, go ahead.
My question is with respect to the previous slide. So whenever we type input equal to, so the whatever is being accepted in input, it's always considered as a string. Can you not force input to accept integer or any other type? Because that is why in output 12 you got an error because age is accepted as a string. Can we not force an input to be of a particular type?
So we can force it using explicit type conversion. So for example, in this case, if you want age to be an integer, you can write your prompt in the way I am just sending on chat.
Mm-hmm.
So instead of saying age equal to input, you can say age equal to the input expression inside the type converter int.
Okay, so then
so
the next line, an error. Okay.
Yes, age will directly contain the integer value corresponding to the input that user has given. Okay.
Thank you.
Right. So right now we are using some very simple programs where we are doing one operation at a time. Slowly we will start combining these simple expressions into complicated one. So Python allows you to nest functions one inside other. The function calls one inside other. Okay. All right. So now we will look at the operators. So Python supports many different type of operators. It supports arithmetic operators like plus, minus, multiplication. There are two different kind of divisions. I will go through one of them in details. It has comparison operator to compare two numbers, so equal, not equal, greater than, less than, and so on. It has assignments, so equal, plus equal, minus equal, and so on. So again, we'll do this as we require them. There are logical operators which apply on Boolean values. There are bitwise operators which work on bit values. And the more important operations are membership operations. So when you have a non-scalar data structure which has certain kind of internal structure, you can ask for membership queries if some object is part of that bigger object or not. And you can also ask for identity queries, whether an object X is of type Y or not. So operators will be covered in the class on need basis. Whenever we need certain operator, we will write some program to understand it, and you can ask questions at that time. Okay. So Python supports variables. A variable is a name associated with an object. Okay, so these variables are very similar to mathematical variables. So when we don't know the value of certain thing and we want to assign some name to it, we use variables in mathematics. Similarly in Python, it's slightly different. You associate a name with every object so that you can refer to it in the rest of the program. To assign a value to a variable, you have to use assignment operator. Python is different from certain other languages in that assignment is really a binding. So there is a question. Mohit, please go ahead.
No, that's not me. I think I raised my hand some time ago, not right now. That was from the previous.
Okay. 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 So assignments are used for binding value to a variable. For example, I can say m equal to 64. So what happens whenever you say write such a statement and execute it? It's like in your memory, the memory of the computer, a location is reserved for variable m. The location is big enough so that it can hold the value, whatever is on the right hand side. And you can think of the name m now refers to the location. Okay. Note that unlike C, C++, Java, we are not supposed to give type name to the variable that we are using. Python figures out type by itself. So when we say m equal to 64, Python figures out that this is an integer variable. It allocates a big enough memory for holding the value and then starts referring to this location as m. You can store strings or you can store floating point number in a variable. Okay. So what I mean by the fact that assignments are used for binding, it means that whenever you reassign a variable, say now you start saying f is 2.7183, instead of changing the location that was holding the value of f earlier, or in this case 3.1416, a new memory location will be created and the name f will start referring to this new memory location. Okay. Unlike C or Java, where the same memory location will be overwritten, it will start having the value 2.7183 now. In Python, this creates a new location and the variable starts pointing to the new location. Okay. This has its own merits and demerits. We will discuss them as we go along. So this means that the new value need not be of the same type. I can also say f equal to some string. A new location for a string will be created and f will start pointing to the same thing, to the new location. Okay. So any questions here? Python has identifiers. So an identifier is names that can be given to different objects. So we saw one example is variables, but other examples are functions. So we have a question. Let me just unmute. Yes, Sridhar, please go ahead. You have to unmute yourself.
Okay. Question on the last slide. So when the memory location is switched to a new one, does it garbage collect the old memory, old value as it is, or like, I mean, like, is it retained in the memory for a long time?
So we will go into these issues later, but if Python does some kind of optimization to collect cells which are not used. Okay.
Okay.
But from a programming point of view, we don't have to worry about that.
Okay.
Okay. So Python does memory management automatically. You don't have to worry about locations which are no longer in use.
Okay.
So identifiers are names given to different objects. These objects can be variables, functions, etc. Okay. So an identifier consists of letters, digits, and the underscore symbol. But note that the identifier must start with either a letter or underscore. It cannot start with a digit. And this rule is same as many other languages. The example of some valid identifier is I, count, lab5 where L is capital. So you can use capital letter or small letter. You can mix them. Max underscore profit underscore left, funny, and so on. Some of the examples of invalid identifier are 5J. It starts with a digit. Similarly, min, space, profit. So identifier cannot contain a space in between. And similarly, lab.7. So an identifier cannot contain a dot. Okay. Another important thing to note is that certain names are reserved in Python, which means even though these names follow the rule given on earlier slide, they cannot be used as an identifier because these names have special meanings. So I'll just come back to a question. And the identifiers are case sensitive, which means if you have a capital letter in a name, it is not same as an identifier which uses small letter for the same letter. So for example, ACADS where A is capitalized is not same as ACADS with all lowercase, and ACADS where all letters are in uppercase. So let me come back to Sridhar. Yes, Sridhar. Do you have a question?
No, that was last time. I think the hand was full.
Right. Okay. So yes, so we have to remember that identifier names are case sensitive, which means if you change case of even one letter in the identifier, it represents a totally different name. So how do we choose identifier name in the program? Python does not put any restriction, but from readability perspective, we should follow some simple rules. We should always choose meaningful names for the identifier. For example, if you are using a counter in your program, it's good to have a name as count if this counter is going to be used in a few lines, more than few lines. However, if this counter is going to be used for only 1 or 2 lines, it's okay to name it as C as well. Okay, so it depends on how much use this identifier is going to have. The longer the use, the longer the name should be in general. That's the rule of thumb. You should avoid identifier names like temp1, temp2, or junk1, junk2, which people use very often, because this name temp1 does not convey any meaning. The name should be easy to read and understand. So avoid excessive use of underscores. Underscore typically are used where you will otherwise use a space. So it's used to sort of separate parts of some longer name. Avoid excessive use of underscores. You can shorten an identifier name when there is no loss of meaning. So for example, the word max is used as commonly as the complete word maximum, or there are certain abbreviations which are very common. You can use them. And you should avoid unnecessary long names. So even if you are using a counter for a loop, I think if you name it a loop counter, it is not going to convey any more information than a variable counter or count. And as I said, if the use is restricted to few lines, then you can even use variables like ij, which are like in programming community are used very commonly to refer to loop indices or array indices. Okay. So at this point, we will have a quick quiz. So let me launch the quiz. And I suggest that everyone please keep a pen and paper ready whenever there are quizzes. The reason being, GoToTraining does not support certain kind of quiz. In that case, I will ask you to write down certain expression and then type the answer in the quiz of GoToTraining. Okay, so here we go with quiz 4. So I am sharing the results of the quiz. So in question 1, A, B, E and G are correct answers. A and B consist of letters and underscore only. C is wrong because it starts with a digit and does contain a dot in between. D is invalid because it also contains a dot in between. Now G is correct, however it is strongly advisable not to use this as an identifier because it will confuse people. And finally H is also correct because it consists of underscore and digit and it does not start with a digit. Second one is not a valid identifier because it starts with a digit. Okay, note that part A is not correct choice because Python identifier can contain digit. It's just that they cannot start with a digit. Type of 2.71828 is float. Everyone got it correctly. Type of single character A, type of capital A within single quotes is string. We had a short discussion on the fact that Python does not have a character type. So everything is a string. Everything that is inside quotes is a string. Question 6, int 2.5 is same as 2. Question 7, again you have to note quotes around 3.1516. So the first 3.1516 is a string while the second 3.1516 is a floating point number. str 3.1516 will be same as characters 3.1516 inside single quotes, and this is not same as pi inside single quotes. Okay, so someone got that wrong. Question 9 was again a tricky question. So if you say int and 7.59 within single quotes, you are trying to convert string 7.59 into integer. And Python cannot do it because it cannot find a suitable representation for string 7.59 as integer. If you use float type converter instead, it will be a valid program. So in this case, the answer is an error. And finally, 10th question, even though I have not shown any example where we are nesting function calls, it first converts 7.59 into number digit integer 7 due to int function call, and then it converts that result 7 into string 7 due to str function call. So character 7 is the correct answer. So we'll move ahead unless there are any questions. So I can see one question or few questions. Sridhar, go ahead please.
Quick question. Is min and max are functions in Python?
Min and max, I will have to check. I think you have to import them from some library. Okay. So questions like this. All right. So we can do a quick check on Spider. So if you can see, I have opened my Python shell. and you can see that min is a function in Python. You don't have to import anything. You can directly use it as a function.
Can you do min equal to, like, let's say a equal to 2 first? No, first
Okay.
a equal to 2.
So the fonts are little smaller. I will try to see if I can fix.
Let's say min equal to a.
Okay, now you want to do min equal to a.
Why did it allow?
It does work. Okay, so we will come back to that again, but in short, min is a function defined in Python, and once again, it's like a binding of name min to that function. Python allows you to override function bindings, okay, so then, or override name bindings. So it is allowing you to rewrite min as 2 instead of a function. Okay.
Yeah.
So yes, Python does few crazy things. If you don't use them correctly, then it's a problem. And now let's try doing min25 again. And you can see that the min has been redefined to be an integer 2. Okay, I can no longer call it as a function. Can you see that? So this means the min was earlier bound to a function that was computing minimum of 2 numbers, but you have redefined it, or you have bound it again to a different thing, in this case integer 2, and now you cannot call it as a min function. Another interesting thing would be saying min equal to max and then calling min25, and now you can see that min refers to the function max. It is using the same binding as function max, and now the program is totally confusing. If you ask min of 2 and 5, it is giving you result 5. Okay. So once again, it's advisable not to try things. I mean, you can try it for understanding purpose, but in real programs, avoid mixing names. Always use names which make sense. Okay, calling a function which computes maximum of 2 numbers, min, will confuse everybody. All right.
Thanks.
Welcome. So let's come back to our class. One of the important statement in Python is assignment. In fact, even without discussing it, we have been using it. We used it few times just now. So assignment statement in Python has a form. A variable on the left hand side is assigned. An expression which is on the right hand side of assignment operator, which is this equal sign. So this is a simple assignment statement. Later we will see that Python has some complex assignment statement as well. Assignment statement computes the value or resulting object of the expression that is on the right hand side of the assignment statement, and it associates the name that is on the left hand side with the value that you computed from RHS. So typically left hand side is called LHS and our right hand side is also called RHS. So in summary, Python assignment statement, it computes the value of RHS and then assigns it to the name on the LHS. The symbol equal is known as assignment operator. Please note that this is not comparison. You do not use single equal for comparison. We will see the comparison operator soon. Some of the examples are, so you can ignore the semicolons. This is a slight mistake. So some of the examples are, I can say x equal to 10, or I can say a variable discriminant square is b times b minus 4 times a times c, or I can even say count equal to count plus 1. Okay. The way assignment statement is evaluated in Python is, first the expression on the RHS of assignment operator is evaluated. Only then the value is bound to the variable on the left hand side. Okay, so this allows us to use a name on both left hand side as well as right hand side without having any issues, okay, without having any problem with the evaluation. So for example, in the third example above, we are using variable count on left hand side as well as on right hand side. However, the way Python will execute this statement is it will first evaluate count plus 1 on the right hand side and then bind count to the new value that has been computed just now. So if count was bound to object 5 before the assignment, during the assignment right hand side will be computed, which will compute a value 6, and count will be bound to object 6 after the assignment. So one way of having complex assignment in Python is having multiple assignments. In this case, you can have more than one variables on the left hand side. So this is again a simple form of multiple assignment, having multiple variables on the left hand side. And on right hand side, you have equal number of expressions separated by commas. Okay, so left hand side variables are separated by commas. On right hand side, equal number of expressions are separated by commas. So in this case, you assign corresponding values to the identifiers on the left hand side, which means 10 gets assigned to X and 20 gets assigned to Y. When you are having multiple assignments, you can have complex expressions on the right hand side. Again, for evaluation, all the expressions on the right hand side are evaluated first before any binding happens. So this is important to note. The left hand side is not looked at all when you are evaluating the right hand side. All the expressions on the right hand side are evaluated. Only then values of the expressions are bound to the corresponding variable on the left hand side. So this allows us to reuse variable names on left hand side and right hand side. So for example, if I have a program where X and Y are assigned 10 and 20 respectively, I can use the next statement which says X comma Y is assigned Y plus 1 comma X plus 1. So first right hand side is evaluated to, let's say, 21 and 11, only then left hand side is assigned. So in this case, X will be bound to 21 and Y will be bound to 11 at the end of these two statements. So I think there are some questions. So are there any questions? Okay, so if there are no questions, we'll move forward. Python programs allows you to write comments in the Python, in the program. So comments are supplementary information to make understanding of program easier for humans. So comments are not used by Python program at all. They are ignored by Python interpreter. In Python, you can write comment by putting a hash sign. So anything written after this hash or pound sign up to the end of that line is considered a comment and it is ignored. Comment is used to supply additional information which is useful for humans to understand the program. So for example, after computing certain values, I can tell why these values are important or what is the significance of these values. Okay, so for example, I am telling that we are computing diameter of a circle and area of the same circle in this program. Okay, so this is where we finished the very simple elements discussion on simple elements in Python. So any questions up to now? Okay. So if no, then we will start with operators and expressions in details. So Python supports several operations, and the typical binary operators and operations in Python are as follows. So Python supports addition. So addition, it works differently for integers and floating point numbers. So if both the arguments of a plus symbol are integers, then result is an integer. If at least one of the argument is floating point number, then it is a result is a floating point number. Similarly for subtraction and multiplication. In Python there are two kinds of division, especially in Python 3. Python 2.7 and earlier had slightly different meaning of division operator. So in Python 3 there are two types of division. One is floating point division, which is a single slash. Okay, so whenever you do use single slash for division operator, it gives you a floating point result. So 9 divided by 2 is 4.25. Python also has integer division, so this is just the integral part of the result. So if I say 9 followed by 2 slashes followed by 2, the result will be just the floating part. We will discuss this operator in more detail in next few slides. And finally you have remainder operator. So this is the remainder which remains after dividing or after doing the integer division. So 9 remainder 2 is 1. Any questions? Python has few unary operators. So for in arithmetic operators, unary operators that take only one are operators that take only one argument or single operand. For example, -5, it takes a single operand 5 and gives you back negative number 5. Python also has a unary operator plus. So you can put it when you want to make it or enforce that the next number which is coming is positive. And similarly, you can use these operators on variables or expressions like -b. So note that plus and minus now have two different kind of purposes or more than two purposes. So when they apply on floating point numbers, their behavior is slightly different. When they are applying on integer, their behavior is slightly different. And when they have a single operand, their behavior is a little different. So the meaning of plus and minus depends on the context. Even though the operator looks the same, it behaves differently. This particular phenomenon is called overloading in programming language community. Okay. Again, this is a very important concept because it allows you to use or reuse natural looking operator in different contexts. So it helps humans in understanding the program better. So let's have some more discussion on integer division operator. So these are two forward slashes without any space in between. So this is also referred to as integer division. The result of integer division operation is a whole integer, or in mathematical term, the floor of the real division. Okay. The important thing to note is the result need not be of type int. If one of the argument to integer division is a floating point number, the result will also be of type floating point. Okay. This is the integral part of the real division and it always rounds toward -infinity. So we'll look at some examples. So 9 integral division by 4 is 2, because if you can see, if you do a real division, you will get 2.5 here. The last example is also interesting. 9 if divided by 4.5, the result of integer division will be 2.0, because 4.5 times 2 is 9. However, we want the integer part of the result, which happens to be 2.0. 1 integer division by 2 is 0 and so on. Okay. So another interesting example is -1 integer division by -2, it is 0. And similar, but if you do -1 integer division by 2, it is -1 itself. The reason being 1 divided by 2 is 0.5. When we have put a minus sign, it becomes -0.5, and we are rounding towards -infinity. So the result of -1 integer division to it becomes -1 and not 0. Okay. So you have to remember these two important points about integer division operator, or three important points, that the type, even though it's a whole integer, it's not int, it's not always int. It is integral part of the real division, and finally it is rounded towards minus infinity. So any questions? Okay, so then we'll move on to the modulo or remainder operator. The remainder operator returns the remainder of the result of dividing its first operator by its second, or we should say integer dividing its first operator by the second. So 9 remainder 4 is 1, because 9 more integer division 4 is 2, which leaves the remainder 1. So 4 times 2 is 8, and this leaves a remainder 1. And once again, the important or the interesting operations are where we are using floating point number as one of the argument. 9 remainder 4.5 is 0.0, because as we noticed earlier, 4.5 times 2 is 9, and so the remainder is 0 in this case. However, the result is a floating point number. And similarly, 1 modulo 0.6 is 0.4, because 0.6 times 1 is 0.6, and this leaves a remainder of 0.4. Okay. So remainder and integer division operator, if you have infinite precision, if you can represent floating point numbers completely, then it follows this identity. A number x is equal to x integer division by y multiplied by y plus x remainder y. Okay, so this identity holds mathematically. It may not hold in programs because of approximations used for floating point numbers, but it will be quite close.
I have one question, Amit.
So let's have, yeah, please, I will go ahead.
Previous slide.
Right.
I thought -1 integer division by 2 was -1 because it was rounded towards minus infinity. So that value was -1. So if I take this integer division by this and multiplied by this, okay, it still holds. That's okay.
So it will always hold, yes.
Okay.
So if you can see, -1 integer division by 2 is -1. So if you multiply it back by 2, you get -2, and you add the remainder, which is +1. So the result is -1. Okay. So this identity holds for all numbers x and y, and especially for integers. So let's move on to quick quiz 6. So I think I missed on quick quiz 5. Let's have that first. Okay. So I'm closing the quiz. And let's review the result before we end the session. So the first question, everyone answered correctly. The second question was a tricky one. And unfortunately, if you get it wrong, probably you will have a cascading effect. But these are the things which you have to note for when you are writing program or you are trying to debug your program. So these are the common mistakes that people make. So in first question, we are assigning an integer value to x, which is 5, which is correct. When you evaluate an expression, it does not change the value of variables. Since there is no assignment, x remains same as 5. And after that, the third one is easy if you got second one correct. So x equal to x plus 2, it will evaluate the value of x as 7 and then assign it back to x. So x becomes 7 after that. And lastly, x plus 1 comma x plus 1 will evaluate to 8 comma 8, and this will assign value 8 to both y as well as x. So if there is any question. Please ask. Okay, so let's move on to the next quiz then, the quiz number 6. Okay. So in this case, so -5 integer division -2, it's going to be 2. Since both are negative, you can just ignore the negative numbers and just do 5 integer division 2. And finally, the outermost minus gives you a answer as negative, gives you the answer as -2. Then type of 9 integer division 3 is integer. So whenever both the argument of integer division are integers, the result is also an integer. So the type will be int. For real division, the answer is always of type floating point number. So no matter what is the type of the arguments, the answer is always float. So the result in this case will be 3.0, not simple 3. Okay. And last thing was again slightly tricky. If you did not notice quotes around none. So the plain none will have a type of none type, but because none is inside quotes, it represents a string type. So almost all of you have got it correctly. So if you have any questions, so I'll just wait for a few moments. So otherwise, if there are any comments or questions, I have unmuted everyone. Please say so. And otherwise, you are free to leave. And once again, you will get a poll at the end of this session. Please fill in as much as you can. Give us suggestions to improve these lectures. We will work on it. Okay, thank you, everyone.